Let's talk about parameter passing conventions and the out and the ref keywords as they are used in C#. So here we are in Visual Studio, and I'll just create a variable, set that equal to 10, and then print it out, and then call a method that takes I as a parameter. And print the value out there. And then I'm going to right click on change me, do a little quick refactoring by generating a method stub. There it is. And I'm going to change the value of I. And I'll do something very simple. In this case, I will simply increment that value. Now let's take a look at what that gets us. And there you see the value 10 printed out twice. In other words, calling the method with a parameter of I did not change the value. Now for contrast, let's create a quick class. I'm going to put a field inside of this class. I'm going to make it public just for the sake of the example. Normally fields would not be public. This is just for the example so we can see values. All right, and now some code to make use of that class. And I'll print the value out. And call a method that takes the object as a parameter. And print out the field value inside of that object after calling the changeMe2 method. And I have to generate that stub. And it will have a similar activity. And we'll run this code. And as you can see, I did get a change in the field value as opposed to a change in the variable value. Okay, so the variable value did not change, the field value did. Now why is this? And the short answer is because int is a value type, whereas objects of a class are reference types. So you remember what that looks like pictographically. Let's go ahead and make a picture of that. So we have a variable of type int, which is a value type, and that goes on the stack. And we have AC, which is a reference type variable, and then the storage for that goes on the heap. The storage on the stack is statically allocated, in other words, at compile time. And the storage on the heap is dynamically allocated, in other words, at runtime. So when we pass these parameters into different regions of scope, value type variables are passed differently than reference type. Or another way to look at it, we always pass everything by value. The question is, what value are we passing? So in a different region of scope, if I have a parameter of a value type, in this case I, it's going to be passed a value, and that value is going to be the value of the integer that is passed. In other words, it's going to be this. So in two different memory locations, I have the same value. If I were to change the value in this memory location, it would not affect this memory location. On the other hand, if I'm talking about a reference type variable, I'm still going to be passing a value, but the value I'm going to be passing is the value inside of the reference variable. In other words, I'm going to be passing this arrow. So we're actually pointing, in the case of the reference type, at the same memory location. So if I change the value of the j associated with this reference variable, well, it's the same as the value j associated with the other reference variable. In other words, it's that j. And so if I change it here in this region of scope, it will affect code in a different region of scope. But so far, that's really just the same as the differences we've always seen between value types and reference types. And I'm going to get rid of some of this extra space. And I'm going to set up a new parameter calling situation. I am going to use I, which at this point should not have been changed. It's still equal to 10. And I'm going to write that value out just to reiterate. And then I'm going to call a new method called changeMe3. And instead of passing it I, I'm going to pass it ref of I. And then print the value of I out after the call to changeMe3. And now I'll create the code for changeMe3. And here's changeMe3. And you'll note that it's passed a ref int instead of just an int. And I will do the same code that I had in changeMe1. And yet when I run this code, you will see that the value of I will be updated. So it went from 10 to 11. Pictographically, it looks like this. So you can see that the parameter for changeMe3 actually points back to the variable I, and that means that when I change the value in changeMe3, it actually changes the memory location associated with the original variable. Now there's actually another keyword associated with parameter passing, and that's out as opposed to ref. And so let's try that here. And I'll create the changeMe4 method. And in that method, I will give I a new value. Again, note that when I call the method, I attach the keyword out to the parameter. And when I declare the method, I attach the keyword out to the parameter plus its data type. And we run this code. And not surprisingly, it has changed my value from 11 to 100. So what's the difference between ref and out? And the answer is out means write only. So in other words, I cannot read the value of I inside of changeMe4 until I've actually written its value. In particular, let's say I had tried to read the value I before having written to it. And as you can see, I'm not allowed to do that. I get that error message because I'm trying to read a value that is write only. Now, once I've written to it, it's okay for me to read it, because of course that value came from my own code, that same region of scope. But I'm not allowed to read the value until I've written to it. And so that's what I mean by write only. And that's the only difference between out and ref. It's just a matter of can you read from the variable before you've written to it. So if you have a situation where you don't know whether or not a parameter being passed in has been initialized or not, then you would say that it's out, meaning you're not going to try to read from it because it's not guaranteed to have been initialized correctly until you write to it. And that's parameter passing and the out and ref keywords in C#.